So after the formation of cation and anion, what's after then? What would happen to the cation and anion? So this picture actually gives us a very interesting picture on how what's the interaction between the cation and anion. You notice that in this classroom we've got a lot of cations, but eventually when the anion pass by, okay, they simply stick towards the anion. So there was a mutual attraction between the cation and anion, and this attraction is known as the electrostatic force. So, ionic bond is formed simply between cation and anion. This attraction is an electrostatic attraction between positive and negatively charged. Well, actually, electrostatic attraction happens everywhere, just like the attraction between protons and electrons. So, for cation and anion, it is very similar. Okay, the nature of it is similar. Okay, both of them are electrostatic attraction. So, because of the electrostatic attraction, so certain chemical compounds could be formed. So here we would like to introduce how the chemical formula should be written and how the idea on how the chemical formula writing. Well, in when we write a chemical formula, we have to remember we have to balance the charge of both the positive and negatively charged ions. So if they when the two ions come together, okay, and the charge becomes zero, then this formula will be what we call a satisfying chemical formula of an ionic compound. Well, let's look at this example. Now, we have sodium ion. Sodium ion got a positive 1 charge, and we have an chloride ion which has a negatively 1 charge. So you notice that if one sodium ion pair with one chloride ion, then they come together and the overall charge will become zero. So when we calculate the number, positive 1 plus negative 1 equals to 0. So this is a completed chemical formula. So what should we write is one sodium and one chloride ion come together. That's why the chemical formula should be sodium chloride, NaCl. Okay, and for another example, okay, oh, this time is a little bit different. Sodium ion got a positive 1 charge, but oxide ion got a 2 negative charge. Well, you notice that actually oxide ion got negative 2, and even if we have 1-to-1 ratio, the charge are not balanced. So this time sodium ion will try to find one of his friend, okay, another sodium ion. Okay, when they come together, they will become two sodium ion paired with one oxide ion. So when you get this calculation done, you'll notice that the overall charge now is also zero. So to finish the chemical formula, we have two sodium ion, okay, and one oxide ion. Well, do remember when we are writing the chemical formula, if we want to mention there are two of this ion, then the number should be placed in the lower right hand corner of that particular element. Okay, so that's why we say Na2O but not 2NaO. Okay, so the name of this compound was simply named after the cation and anion. Remember, we always name the cation first and then the anion. That's why this one is called sodium oxide. Sodium oxide. Well, let's look at another example. Well, this time we've got two nitrate ion and one magnesium ion, okay, so that we can get the charge balanced. So when we calculate once again, okay, we have a positive 2 charge plus 2 minus 1 charge. Altogether, the overall charge becomes 0. So the chemical formula we need is 1 magnesium and 2 nitrate ion. But if we write MgNO32, then the overall thing could be confused as, oh, there are 32 oxygen? No, not really. So that's why we need a help with a bracket. Okay, the brackets here mentioning the ion inside with a multiple of the number on the lower right hand corner outside. So that means we've got two nitrate ion paired with one magnesium ion. So when we give the name of this chemical formula of this chemical compound, then this one is simply named the cation first and then the anion. So this one is called magnesium nitrates. Magnesium nitrates. Well, let's look at another higher level example. Now, this time I've got a copper 2 ion and we have two nitrate ion. So, because of one copper 2 ion pair with two nitrate ion and get the charge balanced. So, this one we call it we write 1 Cu and then a bracket NO3 and then 2. Just it, this one looks very similar to the previous one. But the chemical name here is a little bit different from the one before. Okay, this time the name is called copper 2 nitrate. Copper 2 nitrate. Well, the 2 here representing the charge of that particular cation. Well, to be honest, this one is not really charged. Okay, but more accurately, this one should be the oxidation number of this particular cation. But we haven't studied anything about oxidation number yet. So at this moment, you can still imagine this bracket representing the number of charge of that particular cation. So this one is called copper 2 nitrate. Do remember this one is a charge number. So let's take these few questions as an example. Okay, give yourself a pause and then try to think about what are the chemical formula of these five chemicals. All right, I think you have paused and tried to write up your own chemical formula already. So let's check whether you got the correct answer. The first one, aluminum ion got a charge of 3 plus and nitrate ion get a charge of minus 1. So one aluminum ion pair with 3 nitrate ion. That's why this formula should be Al bracket NO3 3. Copper 2 chloride, as we have mentioned, the number inside the bracket means the oxidation number or the charge. So far, we are learning. So that means Cu should have a charge of 2 plus, and then a chloride ion, each of them should have a charge of minus 1. So the chemical formula of copper 2 chloride should be CuCl2. Just to remind you once again, this number should be placed on the lower right hand corner. Calcium sulfide. Calcium had got a charge of 2 plus and sulfide got a charge of 2 minus. That's why the chemical formula simply plays Ca first and then S. This one is CaS. Magnesium ion got a charge of 2 plus and hydroxide ion got a charge of minus 1. So we've got that means we need two hydroxide ion paired with one magnesium ion. So the chemical formula should be Mg bracket OH2, okay, in this way. Lastly is ammonium carbonate. Ammonium is an non-metallic cation NH3 NH4 plus. So these ammonium ions should have one of them, okay, each got a charge of positive 1, but carbonate got a charge of 2 minus. That means we need two ammonium ion and one carbonate ion. Okay, so again, because this one is a polyatomic cation, okay, just like carbonate, it is a polyatomic anion. That's why we need a bracket. But look at here, this chlorine is not polyatomic because that means it only got one atom in this anion, so that's why we don't need a bracket. But if you have more than one element inside this ion, then we need a bracket if you have a multiple of more than one. Okay, so this is how we write the chemical formula. Well, let's look at the reverse one. Okay, we try to give name to the respective chemical formula. Again, give yourself a pause and then try to name this chemical compound. All right, I think you have finished pausing and try to name the chemical compound on your own. So let's have our answer checked. So this one start with copper, because copper is a cation and nitrates is the anion. So this one is the copper 2 nitrates because we said copper should have a charge of 2 plus, and we need a blanket for it. Actually, most of the transition metal needs a blanket as well. Okay, except silver, zinc, and scandium, so on and so forth. Okay, you will learn more about when you need a blanket on this name and when you don't need the blanket. Okay, soon. The next one, Fe and Cl3. We all know that Cl got a charge of -1. That means the C at the iron here should have a charge of 3 plus. So the chemical formula of this compound should be F iron 3 chloride. Iron 3 chloride. The 3 again representing the charge of this iron. And this one, it looks a little bit weird because we have two things together and we have a dot joining the two together. These dots representing the later thing actually incorporate into the structure of the chemical form, the crystal of this chemical formula. Okay, so this one start with Zn. Okay, this one is zinc. Okay, and then SO4 is sulfate. So that's why this one is called zinc sulfate. But the dot together with 7 water means we incorporate 7 water into each unit of the zinc sulfate crystal. So we have to incorporate this name into the whole chemical formula as well. So the name of this compound is called zinc sulfate 7 water. Zinc sulfate 7 water. Okay. The last one is copper. Copper starts first, and then we have a hydroxide ion at the back. Okay, with two of them. Okay, that means copper should have a charge of 2 plus. That's why this one is called copper 2 hydroxide. Well, after the naming exercise, hope that you can understand more about how to how to write a chemical formula of an ionic compound, together with knowing how to name a chemical compound of an ionic compound. Okay. Well, let's have the following misconception check before we end this session. Cation and anion will form ionic bond whenever they are close enough. Is it correct? The answer is yes. Okay. Whenever we have a cation and anion, no matter are they all the cations are the same or the anions are all of them are the same. Okay. Whenever there are cations and anions, when they get close enough together, then they will form ionic bond without any problem. Just like two magnets. Okay. When you have numerous magnets joining together, okay, you don't really care about they are ball-shaped magnet or they are thin sheets like magnet. Okay, when they get close enough to each other, they will have attraction with each other. Second question: one cation can only form ionic bond with one anion. Is this correct? Well, the answer is no. Well, the reason for no is because cation is actually form attraction force with the anion in a uh, multi-directional manner. That means if you have a cation like this, okay, and then you have a anion like this, they will also form another bonding between these two ions. Okay, so no matter which direction that you have, the mutual attraction is the electrostatic force here. So no matter where you go, the electrostatic force are still there. So do remember, not only one cation will meet with one anion. Okay, there should be a lot more of them. Okay, so this help you understand the reason for this. And let's look at the third question. The third question is, once the metal atom loses electrons to a non-metal atom, ionic bond is formed only on these two atoms. Is this statement correct? Well, the answer is no. Okay, just like what we have explained before. Okay, ionic bond actually happens when there is cation and anion getting close to each other. Okay, so not necessary to be a metal loses electrons and form attraction with b non-metal, because of the b and non-metal gain the electrons from a. Okay, there could be many possibilities. There are bonding between cations and anions, but there's no attraction force between them. Is this statement correct? Well, definitely this statement is wrong. Okay, because ionic bond itself is an attraction force. So we cannot say if we have ionic bond, there will be no other attraction. No. Okay, so this is an idea. The ionic bond between cations and anions can form infinite Hughes structure. Is this statement correct? The answer is yes, because as we've mentioned, okay, actually this attraction force between cations and anions and multi-directional or non-directional. Okay, that means no matter which direction you have the cations and anions, once they get close to each other, then they can pack and continue the attraction. So uh, to be exact, okay, or actually it can form an infinite Hughes structure without ending if there is unlimited amount of compound. I mean, unlimited amount of cations and anions. So hope that this video can let you understand more about ionic bond.